First of all, a little bit of a reminder. Do you remember what complex numbers are? Not everybody at once, it's deafening. Complex numbers. Complex numbers are numbers that have a real component and an imaginary one.
Yeah.
When we have a combination of both, then they are called complex. I assume that because they are not simple. That's the only reason why I would think they're called complex. Anyway.
Why are you taking pictures of me?
So, example 46.1.
How long is this lesson gonna take?
It depends on how much attention you pay. Write the quadratic, look at example 46.1. Write the quadratic equation with a lead coefficient of 1, whose roots are 1 plus 2i and 1 minus 2i. Did anybody understand what it's asking for?
Yes.
Really? Good. Okay. Let's go back to this. It says a quadratic equation. Can anybody tell me what a quadratic equation is?
X squared.
It's got to have a square somewhere, otherwise it wouldn't be called quadratic, right? So x squared
Plus x.
that is a quadratic equation. Actually, this one is a quadratic equation.
Equals 0,
Okay?
right?
Equation, it's got to have an equal sign, so equals 0. Now, they're saying that it has to have, so you need one of those. Out of those answers, you're going to get this. Still, we don't know what to do. So, with a lead coefficient of 1, what's a lead coefficient?
I don't know.
You know, right?
It's a math
When you have
very
the
weird.
parenthesis and the first number is
Lead coefficient. Okay? Either take a note, write this down somewhere, whatever, but know that this is the lead coefficient. If you have a cubic equation like this, then the lead coefficient would be this one. So the lead coefficient is always the one that is in front of the one with the highest exponent. Is that clear? Okay, so they want a lead coefficient of 1, meaning you're going to get only x squared as a result. Do we know what they're talking about? Still sort of lost, so let's keep going. They tell you that these are the roots. What does it mean to be a root? Let's go back to our thick box. Roots. Roots are synonyms for roots. Ah, perfect. Solution. 0. All of these are synonyms. So for root. Root, solution, and 0, they all mean the same thing. 0 not as the number, but the zeros of an equation. Why? Because when you solve this, you equal it to 0. So that's why they're called the zeros, okay? The roots, the solutions are 0. So now we know that those are roots, meaning they are solutions. And if they're solutions, is that correct? Okay? And if they are solutions, and they are like that, it means that x minus would you agree?
No.
Why not?
Because I always say no.
Do you understand?
No.
Okay. Do you understand that these are solutions?
Yes.
Do you understand that if I pass them to that side, it would equal to 0?
Yeah.
Do you understand that these would both equal 0?
Yeah.
And that happens when you have a factor like this, for example. X minus 4 equals 0, x plus 2 equals 0. Do you agree?
Yeah.
That's this case. So we have this, I passed it to this. Is that clear now?
Yeah.
So do you understand why I did this?
Yeah.
Good. So we have that. Now what do I do? Because I need to get to this.
multiply.
Not That's all you do. First you simplify and you've got 1 plus 2i minus 2i. And then x plus 1 plus 2i. And then you multiply and eventually you will get to something like this, okay? If I multiply, I will get
X squared plus x plus 2x pi minus x minus 1 plus 1. Oh my god.
and when you simplify it, you get this. And that is the answer you want. Okay? Is that clear? I'm gonna erase. I need to know if everything is clear. You have no questions on this.
Wait.
Miss,
Yes.
but why, like you have x squared minus x plus 2xi minus x plus 1, y plus 1?
Because 1 times 1.
But it shouldn't it be negative?
That is minus 1.
Which one's minus 1?
Minus x then minus 1 instead of plus 1. Thank you.
Any other questions? May I erase now?
Yes, you may.
Okay. So, now we're going to tell you factor this over the complex roots, and you've got. If they tell you to factor this over the complex roots, it means that you are going to equal this to 0. They give you the original, and you have to equal it to 0, okay? Otherwise, you can't do it. You can't have roots if you don't equal it to 0, correct? So now you're going to go backwards into that. I factor out the 2. I get rid of the 2 because I can divide both sides by 2. So I'm left with just this. And this would be a,
X plus 2 and x plus
I don't know. There's no number, right?
No.
That gives you that. So what do? Our favorite in the whole wide world,
E
Plus minus the square root of
B squared
minus 4ac over 2a.
over
okay, and I think you can take it from there. Do you want me to keep going, just in case? So what would be A?
A1
B?
2
C?
4
So x equals minus 2 plus minus 2 squared minus 4.
It's only
No, it's only 2
4.
there is no minus
Okay.
because of the positive
2
over
over.
times 1. Okay? When I just by a couple of things you should know, or notice at least. This is a 4. And just by looking at this, I know that this second part is going to be larger than this part. Because I've got a 4 times 4. So it's going to be a negative number. And if it's a negative number, it's a square root, it's going to be imaginary. And if it's imaginary, this is going to be complex. And that is why the name of the title was Complex Roots. Okay? So we've got minus 2 plus minus
4 minus 16
4 minus 16 over 2. X equals, can I cancel these two out?
No.
Why not?
Because
Because it's an addition. So
Or
I can, but after I do this. So minus 2 plus minus square root of 8. Negative 12. Negative 12 would be 2 square root of 3. I over 2. Now I can cross out both 2's. And we put a 1. So I've got,
why couldn't you cross out both 2's here first?
because I can factor out a 2, and 2 divided by 2 is 1. So I got 1, negative 1, plus minus square root of 3i. That's it. And that's my answer.